Hello everyone, myself Darshan is pursuing my study at Sri Venkateswara College of Engineering. Today I am here to explain about the operating system for Internet of Things devices. Let us see what is a brief introduction about the operating system. An operating system can be defined as an interface between user and hardware. It is responsible for the execution of all the processes, resources, allocation, CPU management, file management and any other tasks. The purpose of operating system is to provide an environment in which a user can execute programs in convenient and efficient manner. Let us see what does an operating system can be done. Operating system can do process management, second memory management, third CPU scheduling, fourth file management, and the last file security. Let us moving on to this Internet of Things operating systems. The Internet of Things operating systems enables user to perform basic computer activities of an internet connected devices. Internet of Things operations runs on the Internet of Things devices and connects to larger networks of devices. These operating systems offer computer-like capabilities by providing memory and data storage processing capability. These systems may run and process any program that is installed on the device. Operating system for Internet of Things devices communicate with Internet of Things device management software. Not only in this Internet operating things systems, there are various best go-to Internet operating systems available today. Some of the best Internet of Things operating systems are as follows. That is Tiny operating system, Foxey operating system, Windows 10 Internet of Things license, and many more. Now moving on to the parameters of Internet of Things, let us see what are the parameters for selecting a suitable Internet of Things operating systems. That is first, footprints. Since devices are constrained, we expect operating system to have low memory, power and processing requirements. The overhead due to the operating systems should be minimal. Scalability. Operating system may be scalable for any type of devices. This means developers and integrators need to be familiar with only one operating system for both nodes and gateways. Let us see about the connectivity. Operating structures support different connectivity protocols such as Ethernet, Wi-Fi, EEE, and many more. Last, security. Operating systems as a huge security that is adds one that brings security to the device by way of secure boot components and drives for encryption. Let us see what are the open source Internet of Things operating structures. The following is a non-executive list. TinyOS, RIoT, CHONTIKI, or NanoRK, LightOS, Apache MYNet, and ARM Embedded, and Yocto. Some of these have come from academic institutions. Tiny operations and Contiki are almost the oldest. RIoT is more recent and has an active community of developers. FreeRTOS is among the popular ones and it has a good connectivity and low footprint. In zip-hide operating system, the kernel is statically compiled, which makes it safe for compile-time attacks with native code rather than having a monolithic build. Kernel operating structures and apps are expected so and delivered as two. Internet of Things operating system need to be real-time operating structures. There will be also be a class of devices that may not have strict real-time constraints. For some, a richer user interface may be more important. Some may buffer data and transmit them occasionally to save power. Such devices need not have an RDOS and may adopt a simpler operating structures. However, a survey from 2015 has shown that many designers who choose an operating system mention real-time as one of the top resources. Designers may choose to use multiple processors where it makes sense. For example, an 8-bit MCU may be used to interface to sensors and actuators. A 32-bit processor will run the RTOS from connecting and multi-thread. What are the typical memory requirements for Internet of Things operating structures? 250 KB of ROM, 20 requires only 2 KB of RAM and 40 KB of ROM. Similar numbers are quoted from Mantins and Nano Arcade. Apache Monet requires 8 KB of RAM and 64 GB of ROM. If kernel take up only 6 KB, communication protocols typically take up 52,000 kilobytes of ROM, that is random access memory. In all cases, the numbers will increase when more components are added as required by the applications. For example, one experiment with SMX RDOS showed 40 KB or 70 KB of ROM or RAM for node. The same operating systems for a gateway came up to the 200,000 KB or 300 kilobytes. Devices based on Ubuntu Core, Windows 10 IoT, Android Things, and many other likely to require memories in the order of gigabytes. This is because of extra functionality that they are required to device management, security, protocol, translations, data transmissions, data aggregation, data buffering. Let us see about the advantages of Internet of Things. First, scalability. Internet of Things operating systems are designed to be highly scalable, allowing them to support large number of devices and handle a significant amount of data traffic. Second, that is the flexibility. Internet of Things operating systems are highly flexible and can be customized to meet the specific needs of different Internet of Things applications and devices. At the third, security. Many Internet of Things operating systems are built in security features such as encryptions and secure boot to protect Internet of Things devices from unauthorized access and data breaches. At the last, integrations. Internet of Things operating can integrate with a wide range of hardware and software components, allowing them to work seamlessly with other devices and applications. Thank you
Now
for
let's
watching my
see what
channel.
are the
Please do
open
like,
source
share,
Internet
and
of Things
subscribe.
operating